Today we're going to be continuing the discussion of eccentricity in each of the conics graph. For each of the conics we have different eccentricities, which for the first is a hyperbola, the second is an ellipse, and the third is a parabola. And for each they have different eccentricities. The eccentricity of a hyperbola is greater than 1, the eccentricity of ellipse is less than 1, greater than 0, and while a parabola's eccentricity is greater than 1, with a circle's eccentricity being exactly 0. But what do each of the eccentricities mean, and how do we find the eccentricity of each of the graphs? Well, the definition of eccentricity is equal to C over A, the ratio of a segment from any point within the graph to its focus point to its directrix, which I'm going to be showing with an example on the parabola. So we have, for example, defined the focus point and the directrix. So the ratio of this segment to this segment, which is 90 degrees, will be 1. And that ratio will be the parabola's eccentricity. Or in other words, the straight distance from any point within a conic to its focus point divided by the distance, a perpendicular distance to its directrix, will give us the eccentricity. And that applies true for the ellipse and hyperbola as well. Which for the ellipse, its focus point will be somewhere here, along with its directrix being over here, which we should do more precisely with the line tool. The directrix over here and the directrix over here. So, continuing with that definition, the distance, or the segment, you can say this point, but it can be any point, this segment divided by its perpendicular distance to its directrix will be less than 1 and greater than 0, right here, with its definition of eccentricity. And to find the eccentricity of a hyperbola, that would be the same thing. We have two focus points, but we're going to be focusing on the right one. The distance from here to here, the distance from here to here, divided by its directrix, which it will have two, one here, over this perpendicular distance to this, right here. That ratio will be greater than 1. Therefore, maintaining its eccentricity greater than 1, therefore the graph being a hyperbola. And that applies true for a hyperbola opening up and down, a ellipse with its major axes parallel to the y-axis, and a parabola opening left or right or down as well. And this will be the general function of one, where to find eccentricity of a hyperbola, the c will be equal to its focal distance will be square root of a squared plus b squared, and for ellipse, e is also c over a, which in this case, c is square root of a squared minus b squared if its major axis is parallel to the x-axis, b squared minus a squared if the major axis is parallel to the y-axis, and with a being a constant under the x variable. And finally, we have the parabola, which eccentricity will be E is equal to C over A, which the C distance will be 1 over 4A, and the A will remain as A within the general function of y equals ax squared plus bx plus c, or for any other general function represented for parabolas opening down, left, or right.